completely explicit when comparisons and exchanges are happening. It sets it across, it describes the algorithm in time really nicely. It's really, 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 really beautiful. So I could ask you, if you wanted to sort 5 things, don't give me a bubble sort. Think of a clever one. Bubble sort uses too many comparisons. Can you sort 5 things with less comparisons than a bubble sort would take? Did a quick sort? Yeah, come in, come in. It's a little fun exercise for you. I might leave that as a puzzle. You can think about it during the lecture if you get bored. Because then I'm going to ask, what about 6 things? What about 7 things? Can you come up with a general schema for drawing these things to sort n things? These are amazingly fun. I love them. Well, let's implement another more familiar one, maybe, to give you some ideas. Though maybe this is channeling your mind in a particular direction. Maybe you're not going to thank me for doing this. Maybe it's going to be harder to work out how to do this if I keep giving you hints in other directions. You know, it's much easier to think of something new when you haven't got any other things cluttering your mind. But suppose I wanted to do an insertion sort. What does insertion sort assume? Oh yeah, you got a sort?
No, but this is a random thing, but why bits? I remember last lecture you asked.
You're asking me why bits?
Yeah.
Oh, okay. That's a really good question. Can you ask me that like in 1 minute when I finish network sorting, and I'll tell you why bits? Yeah. It's a good question to ask just generally. I think if you're ever in a crowded lecture theatre and someone's talking, put up your hand and go, why bits? See how they handle it. Or ask the bus conductor or something like that. Okay, insertion sort basically assumes what? That everything's already sorted? You've already got a sorted list. Let's look at insertion sort. Suppose I've already sorted... suppose I've already inserted... I've already inserted these guys down here. They're already sorted. Now I'm doing an insertion sort. Suppose that's happened over here somehow. I'm doing an insertion sort. What do I have to do? The only one that I don't know about is this guy. Oops. Is that right? Have I got it right? I don't think I've got it right. I think it's this way. I've sorted these 3. I have a particular reason for wanting to do it one way rather than the other. I've already sorted these 3, and now I just don't know where this value goes. It's going to either, maybe it'll live on this line, or maybe it has to be inserted into here somewhere. That's how insertion sort works, right? How am I going to insert this guy into the right spot? Assuming that in here, as yet undrawn, everything has been sorted correctly on these 3 lines. How would an insertion sort work? I'm going to compare this guy with the one above it. Now, if it passes that comparison, nothing has to be done. If it fails that comparison, it'll swap up to here. I've swapped it one place in. What do I have to do now? Compare again. Yeah. Because maybe that value, it's percolated up to here, needs to percolate one higher. What do I need to do now? Compare again. Does everyone see that? That's how I insert into an already inserted list. So you can probably see recursively what I must have done before is I must have done that, then that in the previous pass, and I must have just done that in the first pass. Does everyone see? This is insertion sort? Yes? Wouldn't the line say, ask it louder? Shh, no, talk louder. Talk quieter, let him ask it louder. Yeah? Yes, I'm comparing the bottom one with every other line. So suppose, let's hypothetically suppose, ignore the circle part yet. Suppose at this stage these guys were sorted. So this is the smallest up here. I'm saying that, aren't I? Can someone remind me? I can never remember which one I say. I'm going to write smallest here so I never forget. Let's suppose that's what I've been saying. So this is the smallest at the top. So this is 1, 3, and this is 5. And I have to insert this value into there somehow. Suppose this value was 7. Then this comparison, nothing will happen. This comparison, nothing will happen. This comparison, nothing will happen, and they'll all be right. Yes?
Like you compare 7 with 5 and not 7 with 3.
Well, no. Yeah, I'm getting there. I see your question. I haven't ignored your question. So suppose 7 was smaller than 5. Guess it was 4. So in this case, it swaps into this position. Yeah. Whenever you compare, if they're the wrong way around, you swap. That's how a network sort goes. So now the 5 is up here, and the 4 is here. Whoop, I should have drawn it there, and the 4 is there. And then I do a comparison here, but the 4 and the 3 are the right way around, so it doesn't swap in. But if it was, say, 2 here, do you see the 2 would flip up to here and the 5 would flip down to there? And now we keep moving along in time, and now we compare these two, which would at that point in time contain a 2 and a 3. Does that make sense? No, I'm flipping the 2 into the right spot. That's in fact how insertion sort often works, is you compare it with the last... Imagine how an insertion sort works. I've got a string of already sorted things. I get one new element. I compare it with the end guy. If it's bigger than the end guy, I put it in place and I stop. This is what's going to give me the linear speed. But if it's not, then normally I shuffle the end guy up one, because I know I'm going to have to move him up one, and I compare this guy with the next guy along. And if he's bigger than that, he goes in the hole I just made. And if he's smaller, I shuffle the next guy up one and put him, and I just keep doing that. So you don't have to actually swap them, but you can. Yeah, sometimes people implement it by swapping it in. Sometimes people implement it just by moving the hole up one. Yeah. But the number of comparisons is the same. But I was being disingenuous when I said no, because if I subtracted these lines here, and I rubbed out the messy numbers that I've scattered everywhere, so it looks like this. Can you see that is in fact exactly the same as that? They're both just an upside down triangle. So insertion sort, in some sense, is exactly the same as bubble sort. But how can that be? Because insertion sort potentially has linear performance and bubble sort never has linear performance.
Got fewer items though.
No, they've got the same. This one does 6 swaps on 4 lines. This one does 6 swaps on 4 lines.
That many items that is significant for a bubble sort to be that slow.
Yeah, but you see, if I added more lines, the triangle would just keep growing on both of them.
Yeah.
So there's no fundamental difference from them the way I presented them now, yet you know in practice the algorithms execute fundamentally differently, potentially. What's going on? What's that? They're in the reverse order. Well, no, they're not even, if you look at it. What's the first comparison done by both? A and B. What's the next comparison? B and C. What's the next comparison? Oh, I've rubbed it out, but... No, I haven't rubbed it out. What have I done wrong? Oh, I've written it wrong. I can't believe. Were you laughing inside again? What have I done wrong? Oh, yeah. Let's have a look. Here's how it goes. You have astutely noticed that this happens before this in this picture. But in this picture, this happens after this. Yes? They do look different. Unless, of course, I do this. Rub that one out and move it along a bit. And rub that one out and move it along a bit. Because rubbing something out and moving it along, what difference does it make whether this happens before or after that in terms of the algorithm? Nothing, because this is completely independent of that. This compares 2 values, this compares 2 other values. Nothing done by this affects the outcome of that or the inputs to that in any way at all, and vice versa. These are causally independent, so we can reorder them in time. This is how parallelism works. Remember we looked at that yesterday when we were doing our repeated differencing? If things are causally independent, we can parallelize them and do them in any order we want. It's only when one thing depends on another that the ordering is important. So actually, we could say bubble sort is this, and insertion sort is this. If I just rearrange things that are temporarily have no relation to each other. And it looks like insertion sort's as crap as bubble sort when I write it like this. The real trick is, and there's no trick, The confusing thing here is a network sort is an oblivious sort. Everything happens no matter what. When you actually do a real insertion sort, remember I said you compare this, you've got a new guy, I'm inserting him to an already sorted list. I pick the new guy out, I compare him with the end guy. If it's already bigger, I put him in spot and I stop. But actually the way I've written it here, even if I don't swap these two, I still swap those two. I still compare those, even though they can't possibly be a swap. Still. So this is what we'd call an oblivious sort. It does its sorts independent of the results of previous sorts. It doesn't change its strategy depending on what case it discovers it's facing. It just does the same strategy each time. And an oblivious insertion sort, were you ever stupid enough to write, not stupid, but were Hollerith 19 to ever write one? He was the dumb one in the family. Who would write an oblivious insertion sort? Once you know you don't have to do any more comparisons, don't do any more comparisons. And in the case of insertion sort, that moves you from n squared to n, so it's certainly worth being the smart one in the family. Okay, so that was network diagrams, so network sorting, so it's sort of fun to fool around with that. So you might want to, again, going back to this, yourself, don't give me the triangle. That would work, wouldn't it? But don't give me that. Think of one that uses less comparisons than the triangle and see if you can come up with something that sorts 5 lines. It's heaps of fun. Second thing I wanted to show you was Bead sort, which is a funny sort. Can I say, Bead sort was invented this millennia, after the year 2000. Now, I started teaching algorithms and sorting back in the 1990s. It's crazy for me to think that since I started teaching it, when I thought I knew the field so well, someone's come along and invented something radically new and different that just blows your mind away, one, and at the same time, is completely simple and obvious, and a child could have seen it. And it really made me think, why didn't I see that? So good on them. It was some brilliant Australians from Christchurch that worked it out. Let me show you how bead sort works. It's just too good to be true. Suppose I'm sorting, it only works if I'm sorting whole numbers. Here's how I'm going to represent the numbers. I'm going to have like some children's beads on slidey rods. And I'm going to have, say, 4 numbers. Number 1, number A, number B, number C, and number D. And I'm going to represent them by just putting as many beads as there are numbers. So this is the number 3. Yep, this is the number 1. This is the number... What other number do you want me to sort?
4.
Okay. What other number do you want me to sort?
4.
Another 4?
1.
1. Let's do another 1 or a 2. I don't care. Let's do a 1. Okay, here's how bead sort works. You arrange all your numbers on the beads. Shh, 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 shh. And then you let go. And they all fall down. Now let's have a look. When they've all fallen down, what does it look like? Those Australians. How many are on this column? 4. So there's certainly 4 all the way up here. How many are in this column? How many are in this column? 2. How many are in this column? 1. So we've got 4, 3, 1, 1. How about that? So, well done. That's all I wanted to tell you about sorts. Let's now move on to talking a bit about science. Oh no, there were some questions. Shh, 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 shh. In the break, some people asked me some very good questions that made me realise I might not have explained something, might not have explained several things very well. I hope I didn't rub them out. I cleverly wrote the questions on the board. One person asked me about stable. You talked and talked and talked about stable, he cried, but it still made no sense. What does it mean for an algorithm to be stable? So here's the example I used. I've got my 4 DVDs. 5, 6, 6, and 10. Let's suppose they're arranged like this. 10, 6, 6, 6, and 5. And I want to sort them into ascending order. Can everyone see that? Which 6 comes first? The black 6 is here. You might not be able to see it all the way from over there, but there's a black 6, then there's a black 10, then there's a red 6, then there's a black 5. Now, I'm going to sort these. I'm sorting them by the key. I've got a key collision. 2 of them have 6. So in the sorted output, they're going to be together, aren't they, the two 6s? But can you see there's two different ways they might be arranged in the sorted output and it's still regarded as being sorted. Maybe the black's going to come first, like it currently does, or maybe once they're sorted, the red's going to come first. And I still regard those two as both being sorted. A stable algorithm will make sure that the relative ordering beforehand is preserved afterwards. So before, which comes first, the black one or the red one? The black one is the earliest. So after sorting, it's going to look like this. 5 goes here, 10 goes there, 6 goes here. It's going to go 5, 6, 6, 10, and which 6 comes first? Black. If I'm using a stable algorithm, that will always be the case. If I'm using an unstable algorithm, sometimes things that have the same key might get reversed. Now, if all you're sorting is keys, who cares? Who cares which 6 was originally first? If you're just sorting 6s. Because a 6 is a 6 is a 6. It doesn't make any difference. But if they're keys where they're attached to videos and they're attached to different videos, you can tell the difference. In your task 1, you're just sorting keys, aren't you? Are you just sorting keys? You're sorting strings. Are you just comparing the strings to work out which is bigger and which is smaller? Or is the key slightly different to the thing it's sorting? What's the key for a string in task 1?
That's the index.
Yes, but suppose I was sorting cat and dog. Suppose I was sorting Richard and Ralph. Suppose I was sorting Richard and Ralph and my favourite number, 12. And 74. So I'm sorting these. Which is going to come first? Well, if I'm sorting strings, 12 will come first. Why not? You always put numbers before letters? No. I hope I didn't strike fear into your heart. No, why would 12 come first? Starts with a lowercase t. Lowercase t clearly comes before uppercase r. What's that? Uppercase comes second. Well, and the random sorting scheme I've just invented. I mean, the order you put on something is entirely arbitrary, isn't it? It's normally convenient that we make it follow alphabetical order, but it's completely arbitrary. What is the key for the strings in task 1? Not the string itself. Not the ASCII value of the string itself. All right, I'll leave it as a challenge for you to read the spec closely. The key is not the string. Because the key is not the string, by comparing strings for colliding keys, you can work out if it's stable or not. But I'll leave it for you to think out what the heck that just meant. Okay, so the first question was stable. The second question was, what's the difference between the MSD radix sort and the LSD radix sort? What's the difference between doing the most significant digit, character first, and the versus doing the least one first? The difference is this. If you do the most significant one first, then your buckets need more buckets. And those buckets need sub-buckets. And those buckets need sub-buckets. And you need to subdivide and end up with lots of buckets. It's like the man going to St. Ives. But if you do the least significant digit first, then after dividing it into buckets and sorting, you can recombine them and then repeat the process. And do you remember that's what I did? We had 4 people standing up here. We just had 4 buckets. We didn't need each of those 4 people having 4 more people and each of those sub-people having 4 more people. We would have needed a lot of people to do that. We just had 4 people. We only ever needed 4 buckets. We sorted them in the 4 buckets onto the floor, and then I just recombined them by handing it back to the people. Do you remember that? So we recombined before sorting each time. So if you trace it through, the LSD one you can recombine. The MSD one doesn't work if you try recombining. So try them out. Rather than me talking about it and waving my hands, it's best seen by actually trying it out on an example with pen and paper. Or with chalk and a blackboard if you've got one. And I strongly suggest this. This is what I did when I was a little kid. I got some blackboard paint and painted a section of one of the walls in my room. You do it when your parents are out and you get the world's biggest blackboard. Absolutely awesome.
Do you actually get blackboard paint?
You can get blackboard paint. It's just black paint that's got grit in it that is frictional. Full stuff. Okay.
Blackboard for sure.
It's called blackboard paint. It's very, very good. You can just paint anything with it. Anything at all. Carry some with you. It's very useful. In fact, there's a stupid whiteboard in this room. I won't say any more. Okay. Let's get back to talking about science. Actually, before I talk about science, I've got your hopes up for no reason. Since we've just finished talking about sorting, maybe I should answer questions about task 1 now, because that's a sorting assignment. So ask me your questions about task 1. Does anyone have any questions about task 1? Yes. What's the difference between vanilla selection sort? Oh, by the word vanilla, I just meant a normal selection sort, so the one we did in class. Quadratic selection sort is the one where it breaks the list into the square root of n groups, works out the biggest in each of those groups and so on. Remember we did that? Any more questions? Yes?
Shell sort times 4.
Oh yeah, what shell sort times 4? So a shell sort, we need to know the sequence of intervals used to shell sort. So the sequence in a shell sort times 4 is we're using the intervals 1, 4, 16, 64, 128, so on. Does that make sense? Where's the person asking the question? Wave at me. Yeah. So that's what a shell sort times 4 is. That gives you the intervals we use. So of course we apply them in reverse order. A shell sort, what was the other shell sort? Times 3 plus 1. You can probably guess what that's going to be. 1, 4, da 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 da. Okay. Okay. Yes?
Is the mystery sort radix, or is that just mystery?
No, the mystery sort's a mystery, I could tell you, but then you'd know. Yeah. I might actually write in what it is tonight. Tonight I'm going to go over the list of all the sorts and look at them and try and finalise them. And I might tell you what the mystery sort is. Who wants me to tell them what the mystery sort is? Is it BOGO sort? Let's say it is. Okay. All right. So BOGO sort, you're going to have to do a bit of looking up to work out what BOGO sort is. Okay. Shh. Any more questions about task 1? What's a BOGO sort? Oh, I can't tell you that. I could tell you, but it wouldn't be a mystery. You have to look it up. Yes.
How do we give input to these algorithms?
Shh. How do you give input to the algorithms? So there's a sort function you run. You won't be able to run the sort program till the phase 1's handed in. I think phase 1 was due Saturday night, but now it's due Sunday night. You got a day extension because we were late getting the spec up for reasons largely beyond our control. i.e. the website went down. Well, actually, the whole CSE went down. What question was I about to answer on this beautifully clean board? Does anyone remember?
How do you give input?
Oh, how do you give input? Yeah, so we've got a sort function for you. I can't remember the path to it. It's something like tilde CS1927 slash check this just before you run it because something bodgy was put in the draft spec. It's probably something like task 1 slash sort A. Or maybe it's sort 1, I can't remember. That's the name of your function. So if you go to Unix and you run that program, here's your Unix command line, you type that to run it, that will run the sort program. Now it's expecting some input, and it's going to read all the input from standard input. So you could just now type in all the strings you want sorted. But can you see how that's going to muck up your timing? Like if you had to type in 1,000,000 strings, probably the slowest part of it's typing them in. So best to redirect them in from a file. So previously set up all the strings you want sorted in a file. Suppose it was called test12 b.text, say. You might have 1,000,000 of these files to test different things. To send this input into the function, you just go, it's just a Unix thing. Pipe it into, read it from, redirect standard input to this file. That will sort it, and it will then print out on the screen the sorted list. You might not want it to actually print out the sorted list because you only care about the time, you don't want to see the output. And the printing out might waste a bit of time and might muck up your timing because I/O is always very slow on a machine compared to other things. So there's a flag you can give to tell it not to print out the sorted list. Does anyone remember what that is? You could redirect it to null, but it's still generating the output and printing it, so it might be spending time. You can redirect it to null if you want, but you can do a /q. I don't think I left enough space there. -q for quiet, and it won't print out the output. Does that answer? Yep. That's for any of our sorts. Yep. Yep. Hang on.
Are the strings separated by new lines?
Yeah, strings are separated by new lines. Yep. Good. Excellent. Good question. You'll have to be faster next time.
Our tutor said you hadn't told him like what folder to put the wiki thing in for.
Oh, yeah, if you, that's up to him to pick a name. The question was, what location do you store your report? You got a question next or a question related to that? Oh, I've seen you. Okay, I've seen you. And I just remember, you've had it up for a while, I'm sorry. It took me a while to remember. That's the danger with sitting up, you know. I kept seeing you thinking, oh, he's got his hand up. Oh, so where do you put it? Yeah, has everyone created their homepage on the wiki? When you create your homepage, there's a template. I mailed everyone else telling them about the template. That template's got a link that when you click on it, that's the right spot to go. But at the moment, the link will say something stupid in the middle of it, like Richard and Pat. I think I was pretending it was me and someone called Pat who was a team. So that has to be changed to the name of your team. Ask your tutor for the name. If your tutor doesn't know a name, invent a name. Make it a good one. Like, what's your name? Nick. What's your partner called? Harry. So you could call it Nick and Harry. Does that make sense? But follow the link. So create it from the template. If you've already created your homepage, Some of you who are really keen will have created their homepage before I got round to handing out the template. Don't worry, that's no drama. Create another page that's not your homepage using the template. Just create a random new page. Call it stupid page that's not my homepage. And it'll pop up in the wiki. Do you want to use one of these templates? And go, yes, homepage template. And it'll create exactly what a homepage should look like and just copy that and stick it in your other one. Oh, how do you, I haven't told anyone how to delete a page on the wiki, but I can tell you now how to delete a page on the wiki. Here's how you do it. On the last line of every page, you know you can put a category comment. You might have already said category homepage, say. A category understands categories is another category that we did in the tute, didn't we? Yeah. So if you put category, oh, I haven't left enough space, to be deleted on the bottom of any page, then from time to time I look at that category and delete every page in it. Does that make sense? So you can't delete a page, but if you make a dumb page that you don't think ever needs to be there again, ACL it so no one can see it, so it doesn't annoy people, I'll still be able to see it, and then put category to be deleted on the bottom and I'll delete it. Don't put category to be deleted on someone else's page. Oh, yes?
Can our strings just have randomly generated text in response to that?
The strings have to be alpha, upper and lower case. Oh no, they can be anything. That's right, the strings can be anything at all. That's a really good question, thank you. Does everyone get that? The strings are just random collections of alphabetic characters. They have to pass the is alpha test in C. Yes,
So
which means A to Z, uppercase A to Z.
So the four cases, the four test sorts that we have to distinguish between, they
Yes.
will all react the same way to invalid input?
All the sorts will react the same way to invalid input? Probably. If I've done my job right, they will. But if I might leak information, you know, you might get an error saying, warning, stack overflow in bubble sort on 919. Then you've got me. But yeah, I'm trying to make them all exactly the same. Yep. Yes?
The four sorting programs,
Yes?
they seem to be shared. Do they actually magically change to different sorts when we run them?
Oh, no, it's just a black box behind this. He's asking details about how we've implemented it.
But they are different between accounts. And that's
Don't worry about it. Don't worry. Don't worry. It's just not an issue. Don't worry about how it's implemented. That's absolutely our problem, not yours. Yes?
So if you give some like bad input to the program,
Yes.
will it like just print out nothing? Or
Try it
will
and see.
Sort of go halfway and then
Try it and see.
print out like half.
Yep. So the question is, what if you give it bad input, like you got digits in it or something like that? Try it and see.
Well, can we access them now? Yeah.
No, you can't access them till phase 1's finished.
So what if we want to include like, I don't know, using some bad input to help distinguish?
Bad input shouldn't distinguish them because they should all respond the same way to bad input. Yeah.
So it won't, like what I was thinking is it won't crash like halfway through and then you would see, oh, it's bubble sorted the first few and then...
Oh, I see. I don't think so. If you can squeeze extra information out like that way, you're being very lucky and you've outsmarted me. I'm trying to do it so the only way you can tell the difference between them is by their stability and by their time, the time they take. Yep. So there's not supposed to be any tricks or hidden little clever things to do. It's really just literally looking at time and stability. Yes?
Some salts are not stable, but you can intervene in a way which makes them stable.
Yes.
So while you do the
Yes. It's a good question. You keep asking good questions. The problem with stability as a way of just, I nearly didn't input stability in. The problem with stability, there's a question on stability in your tute next week. The problem with stability is that any comparison-based sort can be made to be stable, or you could implement it non-stably. Like bubble sort, you just stop swapping when they're equal, then it'll be stable. Any comparison-based sort, you can sort of add to the key its original position to extend the key, and that'll break any sorts. Yeah, and then, so you can make any comparison-based sort stable. But there are some you cannot make stable, no matter what you do. You can assume whenever possible I've tried to make everything stable that I can. You can assume that. Oh, no, don't even assume that. I don't know because, can I tell you the reason I have to be slightly cryptic? We made a slight security mistake and revealed the source code of the sort algorithms. Publicly posted them on the web page for a little while there. So what I've had to do is trash everything we've done before and completely rewrite everything from scratch so that people that managed to download it don't have any advantage over those that didn't. So I haven't yet written everything. So I don't know. But if knowing whether it's stable or not doesn't distinguish between two sorts, then you don't use that as a test to be able to distinguish between two. I think stability is going to give you very little information. But there are one or two sorts that it's impossible to make stable. Well, there are one or two sorts that you'd have to do a ridiculous amount of work to make them stable. I'm not doing that ridiculous amount of work. Okay. Yeah. But time will tell you everything. You really don't need stability. I wish I hadn't put damn stability in now, but at least it'll make you think about stability. In your report, talk about these things. This is what science is like. Often there are imponderables. Talk about them. Yep. Yes?
How would you tell, like, if you gave it a list of strings and you had the same string?
Yes, that's a very good question. Did everyone hear that question? If you gave it a list of strings, how would you tell, and the same string was repeated, how could you tell if the output was a result of a stable algorithm or not a stable algorithm? Does everyone see that is a vital question to be able to answer if you want to be able to use stability as one of your criteria? Does everyone understand that? Yes. Any more? No. No, I said that before. That's my challenge to you. No, it's not impossible. No, it's easy. But you'll just have to look at the spec and think about it. I talked about it for about 5 minutes a little while ago. But you probably had lost all the blood from holding your hand up for so long with that other question you had from before. So it's quite fair. But I've given you some hints already about it. But basically it's not very hard. Just look at it. Essentially it's the difference between the key and the object is what you've got to hunt for.
But if we're putting in...
Don't talk about it with me. Think about it. Have this dialogue inside your head. Because you'll suddenly get it and then you'll blurt it out and everyone within earshot will know and everyone not within earshot won't know. And yeah, I can already hear people blurting it out and I'm mentally stabbing them to death right now. So if you're suddenly mentally dead, that's me, I'm sorry. Okay, so we're not going to talk about that anymore and it's not terribly important if you don't get it. Are there any more questions about task 1 not involving the word stability? I hardly dare ask, are there any questions involving the word stability? You have a question, yeah.
Would it be against the rules to attempt to reverse engineer the binary?
Don't reverse engineer the binary. Yeah. I want you to work it out without reverse engineering the binary. The thing that tutors say whenever I say some smart aleck or some amazingly smart kid, not meaning smarter, but someone will reverse engineer the binary and work it out that way. And that really annoys me if that is possible. I'm not annoyed at the person, I'm annoyed that that is possible because I want everyone to use analytical skills to work it out, not reverse engineering skills. And the tutors always say, oh yeah, but if they're smart enough to reverse engineer it, then let them go for it, that's good. To which I say, pah! Because this isn't a test of how smart you are or if you know how to reverse engineer. This is precisely a test of your ability to make in decisions based blah, 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 blah. So if you can reverse engineer it, that is awesome. And I'm very impressed. But, I mean, in a sense, you can look things up on Google, and that's awesome and impressive too. That's another way of solving the problem. But I actually want you to go through the process of running 2 programs, seeing how long they take to run on different inputs, and making decisions that way. So yes, it might be possible to reverse engineer. I've tried to set it up so it's not, but it might be. But if it is, and you choose to do that, please do the other way first, and submit your report, then do it, and then put an appendix, by the way, no, I've reversed engineered. And then I'll have to commit suicide. But does that, yeah. So there's nothing wrong with doing it, and I like you trying to do it and thinking of lateral ways of solving the problem, so I don't want to squash that. Continually go through life trying to think of sneaky ways of solving the problem that involve much less work, because that is really what we're doing with algorithms, really, isn't it? That's the whole thing about algorithms. But in this assignment, does everyone understand? I sort of want you to go through the scientific process. And by the scientific process in this context, I mean some sort of systematic planned sequence of experiments that you've worked out in advance that identifies with a high likelihood what sort each sort is by distinguishing it from others, and a series of tests that you run to validate your input and to check that your conclusions are reasonable. That's what I want you to be able to do, some sort of, like you're doing biology. Were there any more questions? With or without the word stable? Yes? Well, why bits? So the question is, if I could expand that question, why do we measure information complexity using bits? So why, if I'm looking at a system of, okay, I've got 4 DVDs. I can arrange them in 4 factorial ways. Oh, okay, no, let's not even talk about arrangements because that's factorial. That's more complexity than we need. I own 4 DVDs. There are 4 DVDs in the world. There are no other DVDs in the world except these 4. It's not too bad if you had to pick 4, except this one. I have in my hand 1 DVD in my shirt. And if you knew that, how much information would you have? Now, there's 2 ways of measuring that information. Or in other words, if Shannon was interested in communication, like over a network or something like that. You're on another side of the world. I know this piece of information. I want to communicate that to you. How much information do I have to send you for you to be able to work out the same piece of knowledge that I have? How much information is embedded in this piece of knowledge? Now, you could say, there's 2 possible answers. It's a number between 1 and 4. So there's 4 pieces of information, and I have to transmit a number between 1 and 4, and that's 4 things. Or you could say it's a number that can be represented using 2 binary bits, so it's 2 bits of information. Both of these seem a reasonable summary of the amount of information in the system. I've selected one of n things, so there are n possible outcomes, so it seems there are n pieces of information. I can summarize those n pieces of information as you know in log n bits. Why did he want to measure the complexity, the information, not complexity, the information content using the bit way rather than the n way? And if you ever study information theory, there's logs appearing all over the place as you convert from the n's to the log n's. And the simple answer, and it's a very simple answer, is this. If we're going out to my place tonight and we're going to watch a video, a DVD, and we're going to have a pizza, and there are, I'll write out how many pizzas are there. There's sorry, swine flu. Suppose there's how many pizzas are there in the world? 6. Okay. I need to transmit the information over to you so you can have a similar party at your place over in your country, and you want to have the same video and the same pizza. So how much information do I have to transmit to you so you know simultaneously the DVD I'm watching and the pizza I'm eating? Now, let's look at the two scenarios. Scenario 1, invented by Hollerith 17, is I'm going to measure n. So I'm going to say there's 4, information here has got 4 bits of, I can't say the word bit, 4, what are the SI units for information? I's. It's got 4i, and this is 6i. And the bit way is saying this has 2i, and this has, what's log to the base 2 of 6? You mean 8? 3i. Okay, they're the two different worlds. Now, separately, each of those things make complete sense. But what about the conjunction of them? How many different ways are there of having DVDs and pizzas? How many different parties could we be having at my place? Can everyone see? How many different parties are there? How many different ways could there be of possible universes could there be for me tonight? 32. How many? That would be 32i. And that would be down here what? 5i. That's what they used to call me at school. Because I was wise and a geek. So, can you see, just from looking at this, why, I wasn't really wise and they didn't call me that, why we picked the B? Can someone summarize it in their own word? Why do we take the logs? Why do we look at the number of bits? Small to store, yes. Yes, I mean they're equivalent, and but that's not why. But that's good. Yes.
You only have to add them.
Yep, that's right. Compositionality. It's serious. When you send a message, you'll often want to send one message followed by another message. And sometimes it's not clear where message boundaries are. And that should be irrelevant. If I'm sending you the DVD and then I send you the pizza, it should be the same as a single message telling you the DVD and the pizza. There's no real difference between those two messages. Can you see? So there's got to be a way of composing things. And the problem is the number of ways doesn't compose very nicely. It composes multiplicatively. So if I've got this message and I concatenate that message on, I have to multiply the two lengths of the messages, and that's sort of confusing. Whereas under the bit way, if I've got two messages and I concatenate them, which is an additive-like process, joining two messages together, then I just have to add together the information content of both messages. Does that make sense? So it doesn't matter where the message boundary is. No matter how you divide your messages into sub-messages, you can just add the parts together and it'll give you the total information. And that is why bits is not really terribly important, is it? But now you know. And certainly if you ever study information theory and you look at logs appearing everywhere, now you'll know why. It's to do with pizza and video and things like that. All right, that was a good question. Are there any more questions about anything? Let's be ambitious. No questions. All right, I have something I want to show you then. This is related to, I had two things I wanted to do. Well, I've only got time to do one of them now. I'll start the next lecture with the other. When I originally was setting task 1 and planning the first 3 weeks lectures of this course, I had a very strong theme in mind. And that theme was, I really wanted you to adopt this sort of scientific way of thinking about things. And by that, I know that's a terrible phrase, it's just a key word in my mind. I wanted you to be able to approach things systematically and methodically. I wanted you to make plans in advance. I wanted you to be very skeptical of any conclusions you came to. I wanted you to test things. And I didn't want you to just be what I'd call, say, a hacker and jump around and try this and try that and see if this works, and as soon as something seems to work, move on. I want you to test it rigorously, plan it in advance, and just do it as though you were doing some sort of scientific experiment. This idea I had, I was trying to explain it to someone, an ex-student of mine, and he said, oh, that is so true. Computing is so often not like that, and it should be. And I said, what do you mean? What do you mean? He said, because I did biology or physics or something. And he's a brilliant person. He's done a million majors in a million things. And he said, when I was doing my biology or physics labs, I always used to think, I would be a bit envious and think, we don't have this in computing. We're so sloppy. And I said, well, what is the difference between a biology lab or a physics lab or an experiment in biology and physics and what we do in computing? And he said something, and I grabbed a camera and recorded him. And I want to show you a little recording of him saying that thing. So let me just try and see if I can do magic. It's only 2 minutes, and I think we've got 4 minutes to go, so we'll have time to sing a song at the very end. Here we go. Let's see if it works. Laptop. Is it up? Go, go. I think it's going to work. Ta-da! Here we are. Oh, there's some code that I was going to show you. That's what I'll show you next week. Let me just put that away and get it. Shh, shh, shh. This is Glenn. Glenn Kelly, a very clever ex-CSE student. QuickTime player. Window. Glenn's movie. Here we go. Is everyone ready? Shut this. Go. Shh.
What we're trying to really get the point across is that we still have to start thinking like a scientist, and part of that is basically to come up an approach to problems in a rational way, in a methodical way, that really kind of emphasizes this point of trying to sit back and think about what you're doing and trying to spend as much time planning what you're doing, planning what the results are going to be what you're doing, rather than just kind of having a go and kind of trying this hit and miss approach. Experimentation is good, but just blind experimentation usually doesn't get you very far.
I see. When you were telling me about this before, you said something that I found really compelling. You were talking about your experience in
biology, first year biology. Yeah. So essentially, it was the assignment was you were given these cell samples, these unknown cell samples, and you had to identify them in certain categories, either bacteria or like eukaryotes or plant cells or animal cells or fungi, different sorts of things. And because you only had a very small amount of lab time, you only had very specific equipment, you were expected to come up with all the analysis you were meant to do, all the plans and the tests and all the logic behind that. You had to plan in advance so that by the time you came into the lab, you knew exactly what you were doing, exactly what you were going to look for, and any anomalous results you could identify at that time. And basically the time you spent at the microscope was much more efficient and much more coordinated.
So you planned in advance, and you carried out the experiments, and at the time of carrying out the experiments you had a very good plan.
Yeah.
And why do you think
I'm saying you plan in advance.
Someone said,
why is that good?
We don't have to do that to watch it.
If someone said,
well, the thing is, a lot of the time we don't.
Do you have to do that? What's the
especially for
point?
simple problems. But as problems start becoming more complicated, and the results of whatever you're trying to do start becoming more ambiguous, you find that you do still need to do it. Because I think the thing about the human mind is we can find patterns in pretty much anything. If you just give us a random plot of data, you can probably try to make sense of it in some way. And similarly with scientific models. If you just have a collection of data and you're trying to fit some model to it, you can make your model as complex as you want. You can fit any data. So really, the only use of a model is to predict previously unknown sets of data. So in that sense, coming at this problem, this classification problem, if you just go and start making experiments and taking numbers and taking ratios and numbers and then trying to say, okay, does this fit a certain sort, does this fit a certain category of cells, you're usually going to self-justify whatever your preconceived notions are. Whereas at least if you come up with a formal way of analysing that before you start, and then you see how the data actually matches your expectations, it's much more truthful to does the data fit your model rather than are you changing your model or are you adjusting your model to fit your data. Yeah.
okay, so that was Glenn. Poor guy. If you ever speak to me after this year and say something interesting, I'll say, just come to my office for a second. Let me record it. But I hope that made sense. I will try and make that, I'll make that so it's a link and you can click and watch it if you need to see it again. Good luck everyone with the task and I'll see you next week.